So what have we learned from this sort of quick tour of SAS architecture? I like stepping back to look at the big picture frequently, especially with my eyes going bad at my advanced age. But the big picture in this case is model view controller, right? And this is the way we're structuring our apps. It is not necessarily the way to structure all SAS apps, but it is the way that Rails has chosen to target because it applies to a large number of apps. So all of the design choices in Rails very heavily favor this. If you try to write an app using Rails and it doesn't really follow MVC, you're going to find yourself fighting many of the things Rails tries to do. And if you're working against a framework, it's a sign that you're using the wrong framework, right? Your app really should be using something else. So specifically in our case, we're going to use databases to store the data. And very shortly, we're going to talk about migrations, which is how we manage the structure, the schema of those databases. We have a notion of CRUD operations. And in the active record model used by Rails, the CRUD operations are sort of part and parcel of each type of model. For the controller, we know that we use HTTP to communicate with it. URIs, ideally RESTful ones that encode a resource and a thing that we want to do to that resource. That's how we specify what is to be done. All of that occurs over the venerable TCP/IP protocols. And for the views, we use HTML and CSS as the way we present stuff to the user. But we can use a templating system like Camel or ERB to combine fixed markup with stuff that comes out of the controller. And you'll see an introduction in one of the upcoming homeworks to XML and XPath. When you're not presenting HTML designed for human consumption, you may very well be presenting XML designed for machine consumption. And there's a number of really great tools that have evolved to allow you to write applications that both generate and consume XML that would come, for example, from another service in a service-oriented architecture. Around 2008, there was a meme going around. And the meme basically was Rails doesn't scale. You can't use Rails to build big applications. Based on what you have seen so far, you should realize that this is a content-free assertion. Okay? Scalability is not a property of a framework. Scalability is an architectural concern. It speaks to, as you increase the number of users, what does it cost to increase the application's capacity so that you don't incur a higher cost per user for each one of those users. You can continue to serve them all with good performance, and the cost per user to do so does not go up, roughly speaking. Now, we saw that one of the choices that was made in the design of the HTTP protocol was to keep it stateless, and that allows you to set up multiple copies, essentially, of an application server and direct incoming requests to any copy that you wanted. That's sort of an obvious way, especially with cloud computing, that you can add more capacity for that particular functionality. But we also mentioned that traditional relational database have some pretty serious limitations in how far they'll scale. We talked briefly about alternatives like sharding and partitioning that are often used to work around those limitations. But at the end of the day, relational databases do have some limits that are imposed in part by the functionality that they try to give you. So Rails doesn't scale isn't really true. Another statement might be relational databases have a limit in how they can scale. And maybe we address that by starting to use some of the so-called NoSQL solutions in conjunction with other models like Data Mapper to alleviate the scaling problems in those parts of the app. And as we'll also see, the intelligent use of caching, essentially keeping a nearby copy of results that you've computed recently, can go a long way towards sort of buying you more mileage out of the database before you run out of scale. So that's not to say that it's impossible to write bad code, right? Even given a good scalable database, you can write bad code that will thwart the database's attempts to be scalable. So I think what a lot of people said when they said Rails doesn't scale was Rails encourages the use of an architectural pattern, the active record design pattern in its models, which in turn requires a relational database to support some of its more advanced features. And if that's what you're doing, it is, in some cases, pretty easy to write bad code that will hit your scalability limit sooner than it otherwise would. And in particular, if you're a novice and you don't follow some of the good design patterns that we're advocating here, this could be a pitfall that you'd run into. But people sort of blame the framework, right? They should have been blaming inappropriate use of the abstractions that the framework tries to provide you. So now it's kind of looking back, we can look at there's these different ways to structure web apps. There's different templating systems. There's frameworks to support each of those choices. But when the web kind of became a consumer mass market thing in the mid-90s, it was the Wild West, right? The biggest web servers at that time were not running in anything that looks like cloud computing today. They were running on mini computers. If anybody is old enough to remember the Alta Vista search engine, the Alta Vista search engine ran on what my PhD advisor, Eric Brewer, called the forklift upgrade model, which is that the way you add capacity to the app is you forklift out the old mini computer and you forklift in a much bigger mini computer. And when there's no longer any bigger mini computer available to buy, then that's it. That's the limit of your capacity, right? And in fact, one of the contributions that came out of UC Berkeley at that time and out of Professor Brewer's research group, which I was very fortunate to be part of, was the idea that you could think about these apps differently. You could use clusters of commodity computers to build them out. And over time, that idea and the ideas about statelessness and replication and so forth that were embodied in HTTP sort of became the perfect marriage. And today, this is the way that substantially all web apps are designed and deployed. So I think Berkeley can rightfully claim credit for being very influential in that aspect of web development. I think the most interesting thing is that over time, and yes, it's probably fair to say that some money was made by certain individuals during some times as a result of the great execution of those ideas. What I think is remarkable is that not only have the patterns, sort of the best practices, been extracted into frameworks, right? That's something that as software people we get accustomed to. Once you do enough versions of something manually, you say, you know, these all have something in common. Can we pull out the common parts so other people don't have to reinvent them? And in fact, that's how Rails was invented. Rails was pulled out of a specific application that was built, and then its author said, you know, this particular way of structuring model view controller apps could be used by other people. So they pulled the Rails framework out of it, really. What's interesting to me is that we're still using protocols that really date from the late 1960s. We're using a markup language whose ancestry is in the 1960s. We're using browsers whose basic architecture was developed in the 1990s. But despite all that, a web server from a couple of decades ago still works, right? The amount of interoperation afforded by following these principles of separation, having protocols, understanding data serialization and deserialization, these principles are really powerful because it means that the degree of compatibility that we have across like 30 years of the World Wide Web is truly remarkable. So that's really where I see the big value of frameworks and applications and design patterns. It doesn't always get the credit it deserves. Lastly, remember that architecture is about making choices among alternatives. And we've tried to show every time we're making a choice in this course, what are some alternatives that we're leaving on the table and why? So we're using, because we're designing web apps, the web is fundamentally a client-server system, but there are some systems for which a peer-to-peer architecture would make more sense. We're going to be deploying on cloud computing, which is shared nothing. We have individual machines that can handle multiple copies of the application server. But there are scientific applications, for example, where that organization gives you terrible performance because the applications are such that sharing is required among different machines working on different parts of the problem. We're going to use model view controller because it is a natural mapping for applications that are user-facing and have to manipulate data. But we showed that for simpler applications, there's also other ways to organize them that might actually be simpler, might actually help you get your app off the ground faster. Rails has chosen to use active record because, as we'll see when we talk about some of the more advanced features, it makes it very easy to establish very powerful relationships across different model types and to manipulate those relationships because it takes advantage of what relational databases already let you do. However, you might be in a situation where, for scalability reasons perhaps, you can't use a relational database. In that case, it's nice to know that there exist other patterns like Data Mapper that allow you, at the expense of more complexity and giving up some functionality, to be able to get around those limitations. And finally, we talked about RESTful URIs. The idea is that the URI describes a resource and a thing to do to it. It is entirely self-contained. You might notice that there's a lot of even modern web apps out there that don't work according to this principle. The same URI does different things depending on what you did last on the application. Or there's a sequence of URIs you have to follow to do something, but if you try to issue any of those URIs out of sequence, you just get a meaningless result. So if you want to think about your app as a way of collecting a bunch of related services that could be used in a service-oriented architecture, REST kind of emerges naturally from that. So as you work on other apps outside of this course, this is what you should be thinking about. What are the architectural choices that you should be making? What are the choices that you are constrained to make, either because of a technical limitation like scalability or because you have to be compatible with some existing piece of the system? But you should always find yourself questioning architectural choices because that's the way that software really moves forward, is to understand what is the right tool for the job at different points in the evolution of your systems. So to summarize, we've seen model view controller, a well-known architectural pattern, but not the only one, for structuring applications that are user-facing. Rails chooses to codify its structure as MVC, so all of the choices it makes are designed to make it easier to do that kind of app. If you're doing non-MVC apps, you will find yourself trying to work around what Rails gives you. And in terms of the way that those components are implemented, views are done with either HAML or embedded Ruby. It's transformed to HTML before the browser sees it. Models are stored in a relational database. And active record gives you a lot of automatic support for mediating between the stored representation of a model in the database and the version that you operate on in Ruby. And controllers just tie those things together by being connected to a routing subsystem that allows incoming URIs to be mapped to controller actions and allows the controller to name what views should be instantiated to return to the user, what data gets interpolated into those views, and so forth. And that concludes our high-level tour.